Hey everyone! We're going to introduce ourselves to a new chapter which is going to be about gases and pressure. So, in this section, we're going to introduce us to the characters of gases and a little bit of introduction to pressure. So, as an introduction to gases, one thing that we have to know is that a lot of elements are already gases at ordinary temperatures and pressures. A lot of them, like helium, neon, argon, krypton, and xenon, these are all monoatomic. Mono meaning one, atomic meaning atom. Other elements like hydrogen, nitrogen, oxygen, fluorine, and chlorine are often found as gases, but they are done so in diatomic states, di meaning two. There are also many compounds that are considered gases, and usually these are going to be made up entirely of nonmetallic elements. Mostly, a lot of these are going to be molecular compounds. Things like carbon monoxide, carbon dioxide, methane gas, propane gas, and ammonia. And then to make sure that we're encompassing the word gases versus the word vapors, gases are going to be gases at room temperature, but vapors are substances that are generally liquids or solids under regular conditions, but can be turned into a gaseous state, such as water is a liquid at room temperature, but it can be turned into water vapor if it gets hot enough. Other couple characteristics of gases is that many gases actually have different chemical properties depending on what elements make them up in their bonding, but they do still have similar physical properties. So, some physical properties that they tend to share is that they expand spontaneously to fill their container, which means they have no definite shape or volume. They are highly compressible, which means that when pressure is applied to them, they can decrease their volume. This is why we have scuba tanks or we have pressurized gas. And then one thing to also note is the reason that they're also highly compressible is because their atoms are spaced relatively far apart. So when they undergo that pressure, the pressure can move those atoms closer together. Now, a little bit of introduction into pressure. What exactly is pressure? Our book defines it as the amount of force applied to an area. So typically, our equation is P, which is pressure, equals force divided by area. Notice that area is a capital A here. This also is going to bring into account that gases exert pressure on any surface that they come in contact with, because gases, while they are tiny and they are very lightweight, they still do have a mass. In fact, we have atmospheric pressure or pressure from the atmosphere or air being pushed down on us at any given time. And typically at sea level, atmospheric pressure is about 101 kilopascals or 1.01325 times 10 to the fifth pascals. So we're going to learn that PA stands for Pascal. So how exactly do we calculate pressure or atmospheric pressure? Well, in order to calculate pressure, we have to know both force and area. And if we're not given one of those two, we have to learn how to find it. In integrated science, we talked about force and pressure. So here's just a little bit of reintroduction. A force is defined as is going to be the product of an object's mass and its acceleration. So acceleration here is going to be a lowercase a. Make sure you differentiate that from area, which is a capital A. The equation is F equals ma. One thing to know about F is this is our unit for force. This is going to be in newtons, which is 1 kilograms times meters per second squared. Important mass needs to be in kilograms, so if it's in grams, we need to switch it out. And then the other thing about A, which is acceleration, that is typically going to be Earth's gravitational force, which is 9.8 meters per second squared. If you do not know area, area can be calculated by taking length times width, and typically area for our purpose of pressure is going to be in meters squared. So if pressure equals force divided by area, because it's the force exerted over an area, we also need to talk about, well, what are some common units? Our SI unit of pressure is going to be the Pascal or PA. Notice that PA is newtons per meters squared. However, other units are used to measure pressure. Bars or pounds per square inch, or PSI. That should sound familiar because that's what you use to fill up your tires. That's what pressure we go by. Atmospheres, or ATM, this is actually going to be a super common unit that we use most of this chapter. And then millimeters of mercury, or mmHg, or torrs. So let's do some examples where we calculate it. It says calculate the pressure in pascals produced by a force of 547 newtons acting on an area of 4 meters squared. So if we look at this, remember pressure equals force divided by area. Here we're trying to find what is the pressure, so we're going to plug in X for pressure. And then we know our force is 547 newtons. And then it says our area is 4.0 meters squared. So 547 divided by 4, we get about 136.75. However, we do want to make sure that we're still taking into account sig figs. So here I only have 2 sig figs, so I need 200 sig figs in my answer. You can do this one of two ways. You can do 140 pascals, or you can write it as 1.4 times 10, 1, 2, as the second PA. For our second example, it says the pressure of a gas contained in a cylinder with a movable piston is 324 pascals. The area of the piston is 0.5 meters squared, and it wants us to calculate the force. This is going to be a little bit of spin-off of the equation that we talked about, which is pressure equals force divided by area. Here it says we already know our pressure, so we're going to plug in 324 in for our pressure. It's going to equal our force, which we do not know, so I'm going to plug in X, divided by area, which it says it was 0.5. Here, we're just going to do simple solve at this point, which is cross multiply and divide. So 1 times X is X equals 324 times 0.5, which is 162. Here we can only have 1 sig fig because of my 0.5. So we can write this as 2 times 10 to the second newtons, or we can just round this out to 200 newtons for our rounding. Now, what if we're a little bit different? Here, we're going to ask you to find pressure, but one thing we're going to note is that it says that our mass is 478 kilograms and our area is 25 meters squared. But if we remember our equation is pressure equals force divided by area, we're going to see that we don't have a force. This is where we're going to have to take into account what is the equation for force. And if we go back several slides, we're going to see that force can be found by taking the mass in kilograms times acceleration, which is going to be 9.8. So if we look at force equals mass times acceleration, force is what we're going to try to find, so that is X, equals mass, which has to be in kilograms, which it is, 478, times acceleration. Acceleration is always going to be 9.8 if something's pushing down on it, because that's atmospheric pressure, so 9.8. We're going to solve this out, 478 times 9.8, and you're going to get 4684.4 newtons. Now that I've found my pressure, I can actually now do this equation. I can then do pressure equals my force, which we found out, and then our area, which we know as 25 meters squared. And if we divide those two numbers, we get 187.376. Here, my answer can only have 2 sig figs, so 190 pascals, or if you want to put it in scientific notation, 1.9 times 10 to the second PA is acceptable. And then on our last one, this is another example where it's asking us to find the pressure when it says our mass is 284,000 grams and our area is 36 meters squared. If we look at our equation, pressure equals force divided by area, we're going to see that I'm not given a force, so I need to use the equation force equals mass times acceleration to find it. So if I'm trying to find my force equals mass, we have to remember mass must be in kilograms. So remember, if we're going to go from grams into kilograms, we need to divide by 1,000 or move our decimal place 1, 2, 3 to the left. So when we do that, we actually get 284 kilograms times acceleration due to gravity, which is always going to be 9.8. So 284 times 9.8. We originally get a force of about 2,783.2. Now, when we look at this, 2,783.2 newtons divided by 36 meters squared, we get about 77.31 repeating. I can only have 2 sig figs because of my 36, so 77 Pascal would be my final answer. Last thing that we're going to look at is gas pressures can actually be expressed in so many different units. So you should be comfortable converting between pressures from one unit to another. And so here I have all the conversions laid out. These are all equal to each other, so you can set them up as a conversion. 1 atm is equal to 760 torr, which is equal to 760 millimeters of mercury, which is equal to 1.01325 times 10 to the 5th pascals. These are all equal. So I can put 1 atm is the same thing as saying 14.7 psi. Or I can say 760 torr is the same thing as 101.01325 bars. These are all equal to each other. So we can use them as conversion factors. And so here we're going to practice. Here it gives us a starting value and what we're trying to get to. Just like any conversion, we're always going to start with what we're given. So here we're given 0.357 atm. Just like any conversion, if we're trying to get rid of atm, it's going to go on the bottom, and then we're trying to get to torr, so it's going to go on top. The numbers that we fill in here have to come from this conversion here. So notice atm has the number 1 in front of it, so that means 1 is going to go here. If we look at this, what's in front of torr is 760, so that means up here with torr, we're going to put 760. If I actually do our conversion, we multiply what's on the top and divide by what's on the bottom. So 0.357 times 760 would actually get me about 271.32. I want 3 sig figs, so 271 torr would be my final answer. Here, again, just like any conversion, we're going to start with what we're given, 26.7 psi. If we have psi and we want to get rid of it, remember conversions, you have to put it on the bottom. So psi would go on bottom. And if I'm trying to get to atmospheres, atmospheres would go on top. Remember, whatever numbers are right here are the numbers that we get from up here. So 118 should go with atm and 14.7 should go with psi. So 1 atm and 14.7 should go with psi. Again, note this is on the bottom, so 26.7 divided by 14.7 will actually get me about 1.816326531. If I'm going to keep 3 sig figs, 1.82 atm or atmospheres would be my final answer. Last but not least, let's do this last one, 147.2. This one is kPa. And I want to get rid of kPa and get to torr. So kPa goes on bottom and torr goes on top. So if I go back to this, we note that 760 is always attached to torr. So 760 torr. And if we go back to this, we're going to find out that kPa is 101.325. So we need to plug in right here 101.325. Notice, again, we got to multiply by the top, divide by the bottom. So 147.2 times 760 divided by 101.325, you're going to get about 1104.090797. Here we want to make sure we have 4 sig figs, so 1104. Torr would be my final answer for this one. And that's the end of today's lesson. If you have any questions, please let me know, and I hope you guys have a great day.